Hello everyone. So I am taking a digital electronics subject and the code is CC309. This particular subject has 3 hours of lectures per week and you will have 2 hours of practical per week for each batch. The theory will consist of 75 marks paper. At the end of the SEM, term work is 25 marks. You will have to answer 2 tests during the SEM which is 25 marks each, and it is having a final practical exam which is 25 marks. Syllabus copy already you all have got. So we are directly starting with unit 1, that is a number system. Now before going for number system, okay, you should know what is a digital signal and analog signal. So what is a signal basically? A signal is an electromagnetic wave or an electrical current that is used for carrying data from one system or network to another. This particular signal, okay, which carries a information about a phenomenon. In electronics and telecommunication, it refers to a time varying voltage, that is an electromagnetic wave which carries the information. Now signal can be analog or digital. So what is analog signal? Analog signal is a continuous signal in which one time varying quantity represents another time based variable, meaning it is a continuous varying signal. So it is going to have an infinite range of values. Such systems are more difficult to work with. Now examples are temperature sensors, your radio signals, light sensor, then touch screen data are the examples. Like suppose if you note down the temperature in a room, it is going to be a continuous quantity. Like you will have, if you record a temperature at 10 o'clock, continuously the temperature is rising or decreasing, so you are going to have for each second you are going to have a continuous data, and if you plot it, so you will have a continuous varying signal. So such kind you will have a graph. So that is a continuous variable signal. That does not happen with a digital signal. So these are a digital signals. So digital signals are basically signals which represent the data as a sequence of separate values at any point in time, and it has fixed number of values. Like for same example, if you record a temperature at 10 o'clock, and if you record a temperature, if the next reading you take it at 10:30, in between 10 to 10:30 you are going to assume some data. You will not take for each and every second. You will take at 10 o'clock, you will take at 10:30. So you will have these two values. So there will be a finite number of values. It is not going to be a continuous signal. Such systems are easier to work with. Now basically all these computers, CDs, DVDs, they use a digital data. Now let's see some comparison or difference between analog signal and digital signal. As we have discussed, then analog signal is a continuous signal, whereas digital signal is a discrete signal. Analog signal is represented by sine waves, whereas digital signal is by square waves. Now considering the bandwidth, the analog signal, okay, consumes a uh, lower bandwidth compared to the digital signal. Here the bandwidth requirement is high. Analog signals gets deteriorated by noise, meaning when the signal is transmitted from one point to another, it is easily getting affected by a noise. Whereas in case of digital signal, they are immune to noise. Analog hardware never offers a flexibility, meaning once it is done, it will be fixed. Whereas digital hardware offers a flexibility in implementation. Analog signal, it is suited for audio and video transmission. That's why your TV signals, all mobile signals, all these are uh, analog signals. Digital signals are suited for computing and digital electronics. Analog signal does not offer any fixed range, so it has infinite number of values, and there is no fixed range for this. Whereas your digital signal has a finite number, that is digital signals are represented only by zeros and ones. processing can be done in real time and it consumes a lesser bandwidth, whereas your digital signals cannot be processed in a real time manner. So these are some of the differences. So this is about your analog and digital signal. Okay, thank you.